Hey everybody, this is your Unit 2 Formative 1 Video 1 on inequalities. Alright, so this is kind of your first introduction to inequalities. You may have seen these symbols before. Basically, let's just talk about what each symbol means. So this is going to be your greater than symbol. This is going to be your less than symbol. This would be, because the line is underneath it, this is greater than or equal to. And then this one is less than or equal to. And all of these are your inequality symbols that you would use. Okay, so the first thing that we're going to do here is actually write an inequality that represents the verbal situation. So remember when we very first started off the year, we were taking word phrases and putting them into algebraic expressions. That's pretty much the same thing we're doing here, except we're taking a word phrase and putting it as a inequality. So first thing we want to look for is where our inequality symbol is going to go. So V is greater than or equal to 5. So greater than or equal to is that symbol, and V is greater than or equal to 5. The trick here to figure out which direction your symbol needs to face is it's open to the bigger thing. So in this case, V is greater than 5, so it needs to be open to the V. Okay? Next one here, we have 5 more than X is less than 10. Okay, a lot of you are going to think more than here is an inequality symbol. Well, if you remember back from the beginning of the year, more than just means to add. Okay, less than is where our inequality symbol is. Okay, so 5 more than X, so 5 plus X is less than 10. Okay, so you can have an actual operation like addition, okay? You can have an actual operation like addition in an inequality. Okay, the inequality is just coming from this symbol here. There's never more than one inequality symbol when you're writing a word phrase from a word phrase to an inequality. Okay, our next one here, we want to determine whether the given number is a solution to the inequality. So our given number is 2, okay, and we want to figure out if that's a solution to this inequality right here. So same way we used to figure out if it was a solution to an equation, we're just going to plug it in. So 3 times 2 minus 8 has to be greater than 22. Okay, so 3 times 2 is 6 minus 8. 6 minus 8 is negative 2, greater than 22. Well, negative 2 is not greater than 22, so no, it is not a solution. Okay, and that's how you figure out if a number is a solution to an inequality or not. All right, when we graph our inequalities, okay, there's two things that you need to keep in mind. There are closed circles and open circles on your graph. Okay, the closed circle means that the number that you're given is actually a solution. So you're going to use the closed circle comes with greater than or equal to symbols or less than or equal to symbols. Okay, the open circle means that the number is not a solution. Okay, and just the numbers greater than or less than that number are a solution. So the greater than symbol or the less than symbol is what you're going to use there. Okay, so let's do a couple examples actually using that. So we have X is less than negative 1. So first it says write the inequality out in words. So we'd say X is less than negative 1. Okay, because remember it's facing towards the X, so it's less than. You could also write this as negative 1 is greater than X. That would work as well. But it's going to make more sense if you always start with the variable. So X is less than negative 1 because it's close to the X, so that means X is less than the negative 1. Okay, to graph it, you're going to draw yourself a number line. You just need 3 hash marks when you graph these. Put the negative 1 in the middle, and then put one number bigger than negative 1, so 0, and one number less than negative 1 on the left, so negative 2. Okay, and since it's a less than symbol, we're going to use just a open circle, and the numbers less than negative 1 would be to the left. So X is less than negative 1. And there's your graph. okay? There's also something called interval notation. That's where it says also write in interval notation, okay? This is basically just a fancy way of writing out the inequality. So in this situation, your numbers go on and on and on forever to basically negative infinity. Okay, so we're going to start with parentheses, negative infinity, comma, and then they go to -1. Okay, and -1 is not included as a solution because it's an open circle, so we're going to use a parentheses. So when it's an open circle, we put a parentheses next to this number here. If it's going to be a closed circle, like, so let's say this would have been a less than or equal to symbol, it would have been a closed circle, and then this would have been a bracket instead of a parentheses. Okay, next to an infinity symbol, so right here, will always be a parentheses. Okay, our next example here. So we have 9/4 is less than or equal to t. And if we want to read it the other way around, we start with the t, and it's open to the t, so that means that t is greater than or equal to, because there's the line underneath the symbol, 9/4. Okay, draw your number line. All right, so 9/4, okay, is 9 divided by 4 is actually 2.25. So what you could do here is you could actually use 2.25 on your number line. And then a little bit bigger than 2.25 would be, let's say, 2.5. A little bit smaller would be, let's say, 2.0. Okay, you could do that, or you could just come up with fractions that go bigger. You could put it in between two numbers. However you do, as long as your number line goes progressively bigger. Okay, we're going to have a closed circle because it's greater than or equal to, and then t is greater than or equal to 9/4, so that means our line has to go to the right. Okay, so now this time when we're writing our interval notation, we start at the left of our graph, okay? So we always read from the left of our graph. This time on the first one we read from the left to the right, and it started at negative infinity. This time it's starting at 2.25, so, and it's a closed circle, so we're going to use a bracket, 2.25, comma, and then it goes to positive infinity this time. And remember, we use a parentheses next to the infinity symbol. All right, our next one here, write an inequality for each graph. Okay, so basically we're going backwards from what we just did. So we start at -6, and it's the numbers greater than -6, so we could say any variable, let's just say x is greater than -6. It's an open circle, so we don't have a line underneath. Interval notation would be reading from left to right, so there's nothing until we get to the -6. It's an open circle, so we're going to use parentheses, -6, comma, and then it goes all the way to infinity, and a parentheses again. There's your interval notation. Okay, number 2, if you look at the number line here, it starts at 1. Okay, it's a closed circle, and every number less than 1 is what it's pointing to. So we could say x is less than or equal to 1. Okay, start at the, for interval notation, we're going to start on the left here, and it's at the negative infinity. So we're going to go parentheses, negative infinity, because there's always a parentheses next to infinity signs, and then it goes all the way to 1. It's a closed circle, so we're going to use a bracket. All right, and the last problem here. Define a variable and write an inequality to represent the situation. Okay, a restaurant can seat at most 172 people. Okay, so we could say that x equals the number of people at the restaurant, okay, and so therefore x, if it can seat at most 172, that means the number of people has to be at 172 or less. So that means x has to be less than or equal to 172, and there would be your inequality to represent the situation. All right, there is your video. Make sure you bring your notes back to class. If you didn't take any notes, you need to rewatch the video and jot down a few problems. We will see you later.